Good morning, YouTube. This is a quick, sped up little mashup of using the telehandler to set a couple pieces of steel that we did yesterday. Obviously, having a telehandler on a job site with ICF is great because it allows us to get up higher quicker with ICF and any kind of sheet goods we need. But also, it comes in really handy on the occasion that you need structural steel. We've always set our own, even on the really big crazy builds. It's very, very seldom we need a crane. But I did kind of keep it simple because the boys are holding on to one end of the steel there and I got to keep them out of the video. So kind of chopped it up, sped it up, and just showed you. I'll get into more details of the structural aspects of this in the rest of the video, but I wanted to kind of do a little time-lapse, sped up version of it for you guys to see us setting the steel. All right, guys, it's Saturday the 16th of November. Me and Austin spent most of last week down in Dallas at the International Pool and Spa Expo. Great show. Got to see all of our guys. Got to see Aquamatic, EcoFinish, Rental It, plus all the new innovative stuff. Austin was shopping for a new line of hot tubs. So we got a lot of ground covered, but yesterday I was completely pickled. I could barely function. I got in about 2 a.m., had to get up at 5:30 and go pick up this steel right here, which we'd been waiting on. It was going to arrive the Monday before I left. You know, stuff happens. It came Tuesday while I was already gone, so the boys couldn't frame this floor behind me. But this one's actually kind of exciting. I'll give you a quick tour of the progress they made without me. They only worked 3 days and not the whole crew this week. But back here, this is actually the first time I've done something like this. This steel beam is going to support an ICF wall above it. You probably saw at the beginning of the video from the drone that 3 sides of this are just stacked on top of the existing walls to go up to the second story, but the second story does not continue across the rest of the house. You know, behind the camera here, it stops right there. We could frame that wall. A lot of guys probably would, but and you could get close enough from an R value perspective to not make it hurt you that bad. But the real big deal is our prevailing winds and our storms come from this direction here, that is the most exposed wall from storms. So to do this, it didn't actually cost a lot of money compared to framing it. Believe it or not, steel beams are not exorbitant if you have a good supplier. And so we have 3 steel beams going in this house to avoid some massive laminated LVLs. The one right behind my head here that goes back this way is it's spanning about 20 feet. And to hold up that entire second floor, that LVL was actually going to end up being more money than that piece of steel. So if you have a telehandler on site that you can throw them up there, it really doesn't add a lot of money. Obviously, this ICF wall will be more than a framed wall, but it's also better. So I'll take you up there, show you some stuff the engineer and I kind of came up with to make it even better. I will have to throw some false work under it because there's no support under that beam at all except a little bit of staircase. So it's basically spanning, and that concrete wall will be up there as just a giant lintel effectively. So really cool thing. I'm gonna give you a quick tour down here and then take you up there real quick. And a lot more progress probably to happen here next week. We got 1 week before we head out for Thanksgiving. So I'll also be probably working on a couple different pools that we're building and winterizing a few because it's finally getting pretty chilly. All right, guys, you see the 12-foot framing is always a little bit challenging. They'll have to put blocking in almost all of this. So there's still a good little bit to do here. This is a storage room. If you guys remember that flat part of the foam that wasn't nubbed in that earlier video, here's the manifold. It's just sort of sitting here loose, trying to keep it protected. Still got the air pressure on it. Nothing really much to see here except we did, if you guys remember, we ran into that bad situation right before we poured the slab where the pipe for the toilet was off. You can almost see it now that we framed the wall. It should be about 9 inches over here. So we had already bucked out for the shower and the shower back there because this house has got like 0 thresholds. So the slope will go straight from this concrete floor, the floor covering that's going to go over that, straight to a slope, so we can't build up a pan. So we left them out, and then we will pour these in after the fact with a slope to the drain once the plumber sets that officially and finally. So that's what's happening in these bathrooms. That's why you'll see for a little while anyway that they are not complete. But yeah, these are just bedrooms. Boys are kind of just getting it all framed. They're starting to put ceilings up, and then next week they'll probably even start the rafters. All right, guys. When I was a carpenter, my favorite days were Advantech days. It looks like a ton of progress. The job site starts looking massive as you get that plane running. And it's just and it makes everything feel super sturdy. So wish the boys would have had another hour. They would have been completely done with this, and I'd have probably been riding my one wheel around in circles up here for fun. But as it is, they still put a really good dent in it. I know Travis Coleman had asked a question about cold joints in the wall. I think it was him. And when we're going up to a second story, this is kind of how we like to do it. As you guys remember from the last video, there are anchor bolts sticking through the rim board into that concrete. So we just make sure that that cold joint is down inside of the row of blocks. So any little air gaps that potentially get trapped in here during that first pass pour, which hopefully there aren't any, but you know, in the real world, you know, we got hundreds of feet of this. You're going to probably have some little air gap somewhere, but it's down encapsulated in the foam. It's not lined up with a seam that's going to be more likely to leak air. And obviously this rebar is actually full 20-foot sticks that are, you know, about head high right now, because they go all the way down into the original subgrade pour. And that's, I did not have to do it that way. I could epoxy a new run in, be just as effective, but it's not gonna be that big of a deal to reach the block, you know, up and over and set them down in. But real quick, I will talk to you guys about this steel and what pucker factors there are and why I like doing it this way. We've used steel like this. You guys know a lot of the modern houses I built in the last 8 to 10 years have been, you know, really, really crazy spans. Some of them will have 40, 50-foot spans open in a house. And really the only way to get there with something that'll last is steel. The last 3 houses I built that are, you know, really modern have had over 50,000 pounds of steel each in them, just with a skeleton within a skeleton of the wood framing. And it's a really effective way to go. It's not bad if you got the equipment to set it. And they're not quite done with the welding of this beam here to the other one. If I can walk out here real quick, I'll show you kind of what we've done. The beam holding up the floor ties into this beam. All this was sized by a structural engineer, which one thing, if we could have had a 12-inch, we'd have a slightly better situation, because this beam is just below the floor. And we're trying to hide all of that in the framing, but that's what it was going to take. This is a 14 by 43. You might be able to see the writing on it over there. What that means is it's nominally 14 inches tall, but it's 43 pounds per foot. This beam ended up being about 29 feet long, so you can figure out how much that weighs. The one thing I mentioned as an idea, and the engineer really liked it, was adding these rebar loops, which we've welded onto the top of this beam. Because what's going to happen here is we got to frame out on both sides of this. It's 8 inches. The concrete that's going to be centered on that is 6 inches. So right now the ICF would sit on there, but it'd be hanging off on both sides, which would look a little sketchy if nothing else. So basically, by the time we build out about 1.5 inches on both sides, we will be wide enough to be the same width as the ICF. We laid this out as such that the an ICF corner will turn there and be directly where it needs to be. So there will be no bastards except possibly on this steel wall. This gap within the loops is a doorway going to the staircase, which you can see the stair wall on the other side there. The one thing about this, so when we pour the concrete, all those loops will be integral into the concrete. And once that concrete's cured, we've got a 9-foot high lintel effectively across here. It is not going to want to move anyway. This steel beam will actually not be as important after that. But the steel is holding up the floor, and these loops will be integral to the concrete, so they'll never let anything sag because they're going to be part of a rigid concrete beam effectively. But while we're placing the concrete, if we get any deflection at all, it'll pull the entire wall down, which we can't have. I mean, it'll pull the entire floor into a sag. So we will have a bunch of false work. You'll see us do this. I'll show you how we do it under that beam prior to the pour to make sure it stays completely string-lined straight, because it's completely important to the entire floor structure for the first 20 feet of this upstairs floor. And we want it to remain flat and level throughout its life. So that's the important part of during the pour and early cure, is that we keep it completely supported with false work. But then once it cures and we can peel it out, it becomes its own completely rigid structure. So the other neat thing about this upstairs is that it has a bridge going across the breezeway into the bonus room in the garage. So right now these look like two structures, but if you can see over there, we got a buck and there's another one right about there. And that's about an 8-foot wide bridge. And then there's obviously a roof line that goes all the way to the back of the house. And we actually missed a buck. You can see the one they've got pulled out right there. That isn't correct. The plans were a little ambiguous on this phase of it, and it took a lot of figuring, but it needs to be more over here. So I'll get to break out my cut and break saw that I prefer never to use because it's a pain in the butt, but I'll have to put a new buck notch in there for those LVLs. They are double 18-inch LVLs. You can kind of see, I'll see if I can get turned around over here, if I can bend down. So what we did is we just put 2 pieces of floor foam, which makes it 4 inches thick. We put that all the way through the wall and foamed it in. Over here, remember that we are 1 course higher, because this is the exact same level over there, but our floor is effectively sitting right on top of this once it has plates on it. So over here, we were able to pour the top of the wall, but over on where I'm standing, there's another course. So the bucks go all the way through at the top level there. They can just drop in, but over on my side, we have to slide them back into the hole because they actually run through. You can also probably see the buck right there that comes over to here, and that is for the last steel beam that's sitting on my truck. It is I think a 1640 or 1642. So it's a 16-inch high I-beam that will sit below the floor in the garage, but give us a free span. So yeah, guys, I'm hoping next week, we're supposed to have a pretty good week with the boys. I think I got them 4 days next week. I'm hoping to get this bridge built at minimum, and get these walls in here stacked while PD works on getting the some of the framing pushed a lot farther. So then the next pour will be these upstairs walls. There's a gable wall here. That's a 12-12, I think, here, because there's a bonus room up here. And we're going to go ahead and build those walls out of ICF. And then around here, there's one, you can see we started one over there, and then there's one over the entry here, which they've already plated, but they got to take the plate off and get ready to pour a little gable above the entry door as well. So guys, that was the progress this week. I can't say that I was part of much of it, at least until I was here to set the steel yesterday with them, but they did great work, and I love going vertical. I do miss being around the carpentry side of things once in a while. Not every day, certainly, but we are poised to make some monster progress next week, and I can't wait to bring you more progress, and may bring you a midweek video from the pool show. I didn't shoot a ton of video, but randomly they said we were not down this year because we were such a new company. We were just burning the candle at both ends at all3pools.com. However, I think the pool industry as a whole, and really the building industry with interest rates, has all been down fairly significantly this year. And man, if anything I could take away from the show was something happened in the last 2 weeks. I don't know what it was, but something happened that lit a fire under the entire industry. Everybody's got optimism and confidence and is ready to go. And no clue what that was, but something definitely in the last 12 to 14 days really changed a lot of attitudes. It's pretty wild. I can't wait to bring you more. You guys have a happy holidays, and I'll see you soon.